Greetings, ladies and gentlemen. This is Mr. Braun here. This is take 3 of the Molarity review notes. Yes, yes, I did say take 3. This is the 3rd time I have done this. We had a major malfunction in the first time. The second time, I forgot to turn the volume on the microphone. Actually, I forgot to have the microphone on. So there was no words with the video. I wouldn't want to cheat you like this. So once again, take 3, action. We're going to talk today about the molarity of a solution. Molarity of a solution. So let's go ahead and talk about some objectives. Well, first of all, we're going to talk about I can objectives. I can recognize the label for the molarity is capital M. So molarity is labeled with a capital M. Our second objective is that you should be able to write the equation for molarity. Okay, you probably already got that in the notes from the video you watched last night, so you should have that in your notes. And finally, we are going to calculate the molarity of a solution, and we're going to manipulate this molarity equation we have right here. We're going to manipulate that so that we can calculate molarities of solutions. All right, let's jump right in here now and say, okay, what is molarity? Okay, molarity abbreviated capital M, is a concentration. The molarity of a substance, and you've done this before because I can remember working in a fume hood with a 6 molar hydrochloric acid solution. So it was 6 molar, you just didn't know what that was. Well, that means a concentration, and that is a pretty concentrated hydrochloric acid solution for you folks to be working with. Okay, sometimes we'll use like a 0.1 molar hydrochloric acid. So 6 molar compared to 0.1 molar, well, 0.1 molar is somewhat less concentrated. Well, when we calculate the molarity, we know that the molarity is equal to the moles of solute divided by the liters of solution. Now, that looks nice and easy here, folks, but the only problem is we don't have scales that measure moles, so we're going to have a grams. We're going to have to take grams and convert the grams to moles in order to do these calculations. So, the moles of the solute, liters of solution. At times, both myself and WebAssign will give you milliliters. We don't want milliliters, we want liters. So you're going to have to convert from milliliters to liters. So once again, molarity, capital M, is equal to the moles of the solute divided by the liters of solution. Let's jump right in. What I'm going to do is I'm going to work 2 examples, and then I want you to do 2 examples on your own and play the video to see if you got them right. So let's start out with this right here. Go ahead and take a second, pause the video, write the questions down in your notes. What is the molarity if one dissolves 21.1 grams of sodium hydroxide in enough water to make 2 liters of solution? Well, how am I going to tackle this one? Like I said before, we don't have scales that measure moles, so I have a scale that measures 21.1 grams. I've got to flux capacitor that into moles. So what I would like for you to do is actually do that. So you're going to need to find the molar mass of sodium hydroxide and convert 21.1 grams of sodium hydroxide into moles. So pause the video, do that, and I'll be back. Here I am. I'm back. To convert the 21.1 grams of sodium hydroxide into moles, I'm going to use the following. Okay, so do I get a cancel? Do I get a cancel in my conversion box down here? 1 mole of sodium hydroxide on the top, 39.99711 grams of sodium hydroxide on the bottom. Do I get a cancel? Yes, I do. When I do my math, 21.1 divided by 39.99711 grams will give me a value of 0.52754 moles of sodium hydroxide. Am I done? Heavens, no, I'm not done. I need to calculate the molarity now. I have my number of moles. I need to plug that back into my equation to find the molarity. Well, I know molarity is equal to moles of solute divided by liters of solution. I just calculated my moles of solute. I need to divide that by my liters of solution. Well, I can see right here in my problem I have 2.00 liters of solution. So I divide that by 2, and I get an answer of 0.264 molar sodium hydroxide. Now, what does this actually tell me? Well, it tells me that if I measure out 21.1 grams of sodium hydroxide, and I add that 21.1 grams to 2 liters of water, distilled water, 2 liters of distilled water, dissolve it by stirring, and I would have created a solution that is 0.264 molar sodium hydroxide. Now, my next example here, go ahead and write it down, and then we'll discuss it. So write down the example, pause the video. Welcome back. How many grams of potassium hydroxide are required to make 500 milliliters of a 0.282 molar solution? Well, once again, folks, I can see that I have milliliters here. So I'm going to have to convert that to liters. So I'm going to take that decimal, which is right here, and I'm going to bounce it 1 place, 2 places, 3 places to the left. So that's going to be 0.500 liters. So 0.500 liters. Okay. How am I going to do this? This is almost like working the last example backwards. Okay. So what I'm going to do, I need to first find the number of moles. Well, how am I going to find the number of moles? Well, I have a molarity here. I have a liters of solution here. So I'm going to take my molarity equation, and I'm going to manipulate that. Once I manipulate that equation, I know that the number of moles are equal to the molarity times the liters of solution. So moles equals molarity times liters. My molarity is right here, 0.282. My liters, 0.5. So I take those two values, I calculate that to get 0.141 moles of potassium hydroxide. I take that amount of moles now, and I have to determine the number of grams. Well, I can go from moles to mass because I know how to work my flux capacitor. I need to find the molar mass of potassium hydroxide, so go ahead and do that and convert the number of moles to mass. Pause the video. All right, here we go. How are we going to do that? Here's my conversion factor. I have 0.10034 grams potassium hydroxide over 1 mole. Do I get a cancel? Yes, I do. My cancels are right there. I do my math, 0.141, multiply it by 56.10034, and I get the value of 7.91 grams of potassium hydroxide. So what's that tell me? If I need to make 500 milliliters of a 0.282 molar solution, I'm going to weigh 7.91 grams of potassium hydroxide out on a scale, and I'm going to add that to 500 milliliters of water and make sure that that potassium hydroxide is dissolved. That'll give me the 0.2 0.82 molar solution. Now, for these next two, I want you to go ahead and copy down the problem, and I want you to work this in your notebook, okay? The question is, what is the molarity if one dissolves 13.9 grams of ammonium bromide in enough water to make 150 milliliters of solution? Okay, so I've got grams and I've got milliliters. Okay, go ahead and work this problem. Once you get the problem done, play the video again and I will go through how to work this, see if you got it right. Welcome back, folks. Here we go. We need to first find the number of moles. So I'm going to take this 13.9 grams and flux capacitor that into moles. Here's my conversion factor, 1 mole of ammonium bromide over 97.94246 grams of ammonium bromide. Do I get a cancel? Yes, I do. I've now converted this into 0.14192 moles of ammonium bromide. I'm not done yet, though, because I need to plug that into my molarity equation. So I need to find the molarity by taking the equation. Molarity equals moles of solute divided by the liters of solution. I just found my moles of solute. How many liters of solution? Uh-oh. Here we go. We got milliliters again. So I've got to jump this 1, 2, 3 to the left. So it's going to give me 0.150 liters. Okay, when I do my math and calculate it, I come up with a value of 0.946 molar ammonium bromide. Okay, so that is the concentration of 13.9 grams of ammonium bromide divided or dissolved into 150 milliliters of distilled water. Now, my final problem, here we go. How many grams of barium nitrate are required to make 2.50 liters of a 1.14 molar solution? Well, this is like the other example problem we did. The first thing, oh, go ahead and pause the video and work this. My bad. Pause the video and work this. Welcome back. Here we go. First thing we need to do is find the number of moles. In order to do so, I know that moles are equal to molarity times liter. My molarity is 1.14 molar. My liters are 2.50. So when I do my math, I come up with a value of 2.85 moles of barium nitrate. I'm not done because I didn't want the moles, I want the grams. I don't have a mole scale here in the lab, so I've got to find out how many grams that is. So to find the number of grams, I need to flux capacitor that number of moles. So I take the 2.85 moles of barium nitrate. My molar mass of barium nitrate goes on top. It's 261.3368 grams. Barium nitrate. My conversion factor on the bottom is 1 mole of barium nitrate. Do I get a cancel? Yes, I do. Okay, so my label now is going to be grams of barium nitrate. When I do the math, 2.85 times 261.3368, I get a value of 745 grams of barium nitrate. 3 sig figs, that's why I've rounded it to 745. Ladies and gentlemen, this has been our review notes over molarity. I'm Mr. Braun. Have a great day.